So should I start? Let us wait for one more minute. People are joining. Okay. So see, as we were discussing, so these are the angles where the value of omega 1 will be maximum. And what will be the maximum value of omega 1? You just put cos square theta as 1 here. So if you put cos square theta as 1, so it will be 1 minus sin square alpha cos square alpha. This cos alpha will cancel one power. So the maximum value of omega 1 will be equal to omega upon cos alpha. Omega upon cos alpha. Okay. So same I explained here. 1 minus sin square alpha. So it is the value of maximum angular velocity of driven shaft. It is the maximum value. Okay. And angles at which it happens are 0 degree, 180 degree and 360 degree. Okay. Similarly, we can also find out the minimum value of omega 1. Okay. So minimum value of omega 1, again you concentrate on this factor. Okay. In order to have the minimum value of omega 1, there must be maximum value in the denominator. डिनोमिनेटर में मैक्सिमम वैल्यू होगा तो ऑब्वियसली ये रेशो कम हो जाएगा. मीन्स यू विल गेट अ मिनिमम वैल्यू फॉर ओमेगा 1. सो नाउ आवर एम इज टू मैक्सिमाइज दिस ब्रैकेट. ये ब्रैकेट में जो है ये मैक्सिमम वैल्यू होना चाहिए. ओके. सो इन ऑर्डर टू हैव दिस ब्रैकेट एट मैक्सिमम वैल्यू, the value of cos square theta should be minimum. अगर ये फैक्टर जो है, ये जो फैक्टर है cos स्क्वायर थीटा जो वेरी हो रहा है फ्रॉम 0 to 1, अगर ये वैल्यू मिनिमम होता है, ओके, सो व्हाट विल हैपन, it will multiply with sin square alpha. So this product will be minimum. Okay. And minimum will be subtracted from 1. 1 से जो है वो मिनिमम सब्सट्रैक्ट होगा. मीन्स यू हैव मैक्सिमाइज दिस ब्रैकेट. ये आपने मैक्सिमाइज कर दिया क्योंकि ये जो फैक्टर है ये मिनिमाइज हुआ. 1 में से मिनिमम ही आपने सब्सट्रैक्ट किया तो ये ब्रैकेट मैक्सिमाइज हुआ. ओके. एंड देन this omega into cos alpha is divided by maximum value. So you will get the minimum value of omega 1. Got it? Now you have to see what is the minimum value of cos square theta. Minimize it. So minimum value of cos square theta, one can easily say that it is 0. Okay. Cos square theta का जो minimum value होगा that will be nothing but 0 or any other thing. Okay. Cos square theta minimum value is 0, and when it happens, sorry, what are we doing here? Cos square theta का minimum value 0 कब होता है? At what angle cos theta is 0?
Phi.
cos theta is equal to 0 at pi by 2. Am I correct? cos 90 कितना होता है?
1.
cos 90.
Cos 90 is 0.
Okay. So when theta is 0, that is when theta is 90 degree, then cos theta is 0. Cos theta is 0. So 1 minus 0, 1. And you will get the minimum value of omega 1 as omega into cos alpha. Okay. So value of cos theta is 0 when theta is equal to 90 degree or 270 degree. 90 degree or 270 degree. Okay. Please make it clear. We want minimum value of omega 1. So if in denominator, if this bracket, square bracket is maximum value, then obviously the value of omega 1 will be minimum. So in order to make this bracket value as maximum, so minimum should be subtracted. ये जो फैक्टर है इसका जो भी मिनिमम वैल्यू होगा वो सब्सट्रैक्ट होगा फ्रॉम 1, तो यू विल गेट द मैक्सिमम वैल्यू ऑफ द ब्रैकेट. ओके. एंड ये जो फैक्टर है कॉस स्क्वायर थीटा इंटू साइन स्क्वायर अल्फा, इसका वैल्यू डिपेंड करता है कॉस स्क्वायर थीटा पे, क्योंकि अल्फा कांस्टेंट है तो साइन स्क्वायर अल्फा भी कांस्टेंट होगा. ओके. सो वी इक्वेटेड cos square theta as 0 to find out minimum. Okay. And it happens that cos square theta becomes equal to 0 when theta is equal to 90 degree, when theta is equal to 90 degree, or it is equal to 270 degree. So cos of 270 is also 0. Cos of 270 is also 0. Okay. So let us see. It is the maximum value, and for minimum value cos square theta should be 0. So it is the minimum value of omega 1. Omega 1 minimum will be omega into cos alpha, or in terms of RPM, n1 minimum will be equal to n into cos alpha, where alpha is the angle of inclination between the two shaft axes, like this. Okay. So you note down this formula, n1 max and n1 minimum. So n1 max is greater than n, and n1 minimum is less than n. N is constant. Let me know if you are done.
Done, sir.
Okay. So now let us draw the, let me see first. Okay. So next is the polar polar diagram of Hooke's joint. Okay, where it is in with the help of that diagram, it is shown how the angular velocity of driven shaft omega 1 varies with respect to theta. Okay, just a second, just a second. Okay, okay. So let us see that diagram. Okay, here you see one circle. Okay, and you see one ellipse like this. So how this is drawn? So this is the center of the circle and ellipse. Okay, you take radius of the circle equal to omega, equal to omega. Okay, and now you as the driving shaft rotates, that is as the theta changes from 0 to 360 degree. Okay, so you have to show the value of omega as radius at that particular angle. Okay, so suppose at 10 degree, when theta is equal to 10 degree, what is the angular velocity of the driving shaft? It is still constant, that is equal to omega. Okay, so of radius of this circle will be constant. You will show the angular velocity at that angle of required length. This length is proportional to value of angular velocity. So you already know that omega is not a function of theta. It is not a function of theta. Means it is constant with respect to theta. So I have drawn the circle which represents the angular velocity of driving shaft omega. It is nothing but omega, means omega is constant. As radius of the circle is constant, you can say omega is constant. Okay, now let us talk about omega 1. Let us talk about omega 1. So we know that omega 1 has maximum value. Omega 1 has maximum value at what angle? At 0 degree, okay, and at 180 degree, at 180 degree. And this maximum value is greater, this maximum value of omega 1 is greater than omega. Okay, so at 0 angle, when radius of the circle represents the omega, to represent the omega 1, I have to take more length. You can see here, I have to take more length, that is up to this, and this length will be equal to omega 1 max. What is the value of omega 1 max? Value of omega 1 max is nothing but omega upon cos alpha. We have seen omega upon cos alpha. Okay, so as theta will change, as shaft will start rotating, okay, omega 1 will also change, because we have seen that omega is the function of theta, that it varies with theta. Okay, so omega when theta is equal to 180 degree, so we have marked this point, first point. Second point, when theta is equal to 180 degree, then again omega 1 has maximum value. So you measure angle theta as 180 degree, like this, 180 degree, this way. So at this angle also the value of omega 1 is maximum, that is at theta is equal to 180 degree also the value is maximum. So you will show the uh, value, okay, with the help of this line which is just equal to the line at point 1. So you mark the second point for omega 1. Okay. Third, what information we have? We is that omega 1 is minimum. Omega 1 is minimum. Okay. Read it minimum. Eraser. Okay. So omega 1 is minimum here. At which angles omega 1 is minimum? That is at 90 degree. Omega 1 is minimum at 90 degree and 270 degree and 270 degree. Correct. So from here we are measuring angle from positive x-axis at 90 degree. At 90 degree omega 1 is minimum. And what is the value of this omega 1 minimum? That is nothing but we have seen the formula for it, that it is equal to omega cos alpha. Omega into cos alpha. Okay. So you mark the third point, omega cos alpha. Definitely this minimum value of omega 1, omega 1 is less than omega, is less than omega. So that's why ओमेगा का वैल्यू सर्कल पे है, तो उससे नीचे लेना होगा आपको थर्ड पॉइंट. एंड फोर्थ पॉइंट अगेन इट इज मिनिमम एट 270 डिग्री. So here is the your fourth point. Now you have to join all these point with the help of ellipse like this. So this ellipse is showing variation of omega 1. It is showing the variation of omega 1. You can see that at particular angle the radius of the ellipse is different. It shows its angular velocity at that particular angle. So this is called as polar diagram of Hooke's joint, which represents the variations in angular velocity with respect to angle theta. Okay, if you want to show it with the help of graph, so you will plot theta on x-axis and omega and omega 1 on y-axis. Omega and omega 1 on y-axis. So omega is constant with respect to theta. So for that we will get a straight line. उसके लिए straight line मिलेगा omega के लिए, क्योंकि ये constant है. But omega 1 is changing. Initially it is maximum, then it is coming to minimum, then it is again reaching maximum value, then coming to minimum value, and again maximum value up to 360 degree. So here your one revolution will complete and again cycle will repeat. So this is nothing but variation of omega 1. So either way you can show the variation of omega 1. You can use this diagram or you can use this graph. It is called as polar diagram. Okay, for the driven shaft speed. Getting this?
Yes, sir.
Okay. So you can see again one point to note down here is that as the omega 1 fluctuates between maximum value and minimum value, it will happen that omega 1 is equal to omega at four times in one revolution. You can see here at this particular point omega 1 का जो value है it is same as omega. So four times it will happen in one revolution. like this. So now we can also find out that what is particular angle theta, what is the value of theta where omega 1 is equal to omega. Okay, we can also do that analysis and find out those values of angle theta. Okay, so we will see that. You note it down, then we will continue. Okay, done. Noted. Let me know if you are done. Okay, so now let us concentrate on this point, that at particular values of angle theta, omega 1 is equal to omega. So let us find out those values of theta where it is possible. Okay. So condition for equal speeds of the driving and driven shaft. So already we have derived this relation. Okay. So here omega is written as omega 1 into 1 minus cos square theta into sin square alpha upon cos alpha. Okay. So we have to find out when omega is equal to omega 1. Okay, then what is the value of theta? So this factor should be 1. Okay. ये जो पर्टिकुलर फैक्टर है 1 माइनस कॉस स्क्वायर थीटा इंटू साइन स्क्वायर अल्फा अपॉन कॉस अल्फा, सो अगर इसका वैल्यू 1 होता है okay, so if this ratio is 1, this particular ratio is 1, then automatically omega 1 will become equal to omega. Okay, so it is rearranged. This is rearranged. What is separated out is cos square theta. So you separate it out, cos square theta, you will get this expression. Okay, so here it is equated to 1. This will go in this side. Then this factor you can bring this side and cos you can take that side. So 1 minus cos alpha upon sin square alpha. It has been rearranged. Okay, so you can use this equation to find out the values of theta. Okay, where this condition of equality will be satisfied. Okay, so it is the raw form of that equation. You can further simplify it like it is the value of cos square theta. So you can also find the value of sin square theta. It is the value of cos square theta. Sin square theta will be, ठीक है, sin square theta will be nothing but 1 minus cos square theta. So 1 minus cos square theta. So cos square theta का value is this. So 1 minus cos alpha. Okay, 1 minus, sorry, 1 minus cos alpha upon sin square alpha. Okay, like this. And then later on what you can do, you can simplify it first. Then later on you take the ratio sin square theta upon cos square theta. So you will get the your condition in terms of tan square theta. Tan square theta you will get something, and then you can write the equation for tan theta. Okay, so further if you write it, here value of sin square theta is found with the help of this. Then again it is simplified, you get like this, and then later on the sin square theta is divided by cos square theta. So when you solve all this, okay, it will result in this particular condition, that you will finally you will get tan theta is equal to plus minus root of cos alpha. If you calculate the value of theta from this equation, okay, you will get the four values of theta. First what you will do, first you will take only the plus sign. Okay, plus रूट ऑफ कॉस अल्फा. तो ये जो वैल्यू आएगा इससे आप थीटा फाइंड आउट करो. sorry, cos of alpha. You take plus value one time, find out the value of theta, okay, and second theta will be this find out value, say theta 1, ये जो value find out किया, second value of theta will be theta 1 plus 180 degree, theta 1 plus 180 degree, because you know this condition that tan theta is equal to tan 180 plus theta, ये ट्रिग्नोमेट्री आपको पता है शायद, tan थीटा इज इक्वल टू tan 180 प्लस थीटा, तो दोनों एंगल का tan सेम आता है, ठीक है। तो इससे प्लस वैल्यू से आपको दो वैल्यूज मिलेंगी थीटा वन की, थीटा की, एक थीटा वन और दूसरा थीटा वन प्लस 180। दूसरा वैल्यू कैलकुलेट करो tan थीटा का यूजिंग माइनस साइन, माइनस ऑफ रूट कॉस अल्फा, tan थीटा इज इक्वल टू माइनस ऑफ रूट कॉस अल्फा, ठीक है। इससे अगेन यू विल गेट अ वैल्यू ऑफ थीटा, से थीटा टू मिलेगा आपको, और चौथा वैल्यू जो होगा वो दैट विल बी थीटा टू प्लस 180, थीटा टू प्लस 180। सो इन दिस वे देयर विल बी फोर वैल्यूज ऑफ एंगल, ये एक हो गया, ये दूसरा, ये तीसरा, ये चौथा, वेयर दिस कंडीशन विल बी सेटिस्फाइड दैट ओमेगा इज इक्वल टू ओमेगा वन। हाउ वी रीच दिस कंडीशन आई एक्सप्लेन यू, that we equated this ratio as 1, then we separated cos square theta, then from value of cos square theta we found sin square theta, this you get like this, and then after that you take the ratio sin square theta upon cos square theta will be tan square theta, you will get tan square theta like this, you will get this equation tan square theta, tan square theta you will get as cos alpha, you will get as cos alpha. Then from this equation you can write tan theta is equal to plus minus root of cos alpha. In this way you can find out these values. In your syllabus it is clearly mentioned that no numerical should be asked on your second module. Okay. So numerical तो नहीं आ सकता है, लेकिन derivation आ सकता है. Okay. So this is what is next. You note down this condition, tan theta is equal to this, then we will proceed further. So to finish all the contents for today, I will need 10 to 15 minutes more. Then we'll stop there, and in next week we'll start the fifth module, which is based on your belt, ropes, and chain drives. Note it down and let me know. Okay. So next, then as you know that angular velocity of driven shaft is changing. So you know that rate of change of angular velocity is nothing but angular acceleration. Okay. So angular acceleration of driving shaft will be zero because its velocity is not changing. So we can find out the angular acceleration of the driven shaft omega 1. What you have to do, this is the expression we have already derived. You have to differentiate it. You have to differentiate it with respect to time. That is d omega 1 upon dt. You differentiate this expression, then whatever formula you will obtain from it is your expression for angular acceleration. Okay. So if you differentiate it like this omega is constant, cos alpha is constant, it is kept out. Theta is a function of time. So it is differentiated. -1 पावर हो जाएगा -2. Okay. -1 here. Then in bracket, it is the derivative of this. And later on you have to derivative this also. इसका भी आपको बाद में derivative लेना होगा because it is not the function of t. It is not cos square t, it is cos square theta. And theta is again the function of t, means chain rule you have to use here. So you will use the chain rule here, 2 cos theta into sin theta. इसका derivative sin square alpha. And again you have to differentiate the value of theta. So theta is again differentiated, d theta upon dt. So in this way you will obtain the expression for angular acceleration. Angular acceleration, that is nothing but alpha 1. That is angular acceleration of the driven shaft. Okay. So note it down and join back just for 5 to 10 minutes more.